Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this lesson, I want to begin talking about layout, or rather, the process of positioning visual controls and other elements on your application's user interface. And there are several different XAML controls that exist for the purpose of layout, and we'll cover most of the popular ones in this series of lessons. Now, in the past, layout was relatively simple. After all, you were typically only laying out an application for a single form factor, a single device like a phone or a desktop application. However, there are a few new wrinkles introduced as we begin to build applications that can adaptively resize based on the device that we run our app on. And this is one of the new key features in app development on the Windows platform. We'll start with the easy stuff in this lesson, and then we'll build up to the more challenging stuff in the following lessons. Now, before we begin, I want to point out one thing regarding all XAML controls that are intended for the purpose of layout. Most controls have a content property. So your button control has a content property, for example. And the content property can only be set to an instance of another object. So in other words, I can put a text block, and let me just copy and paste some code here into what I've got. I can create here a button with a text block property, but then I also have added an image inside of that button control as well. So whenever I attempt to put more than one control inside of the content property, I get this error, and if I hover over it, it says the property content can only be set once. However, layout controls are intended to host more than one control, and so as a result, they don't have a content property. Instead, they usually have a children property that's of a special data type, a collection data type that can hold XAML controls called UI element collection. In XAML, as we add new instances of controls inside of the definition of our layout control, we're actually calling the add method of our layout control's UI element collection, or rather just the collection property. So here again, XAML hides a lot of the complexity for us and makes our code very concise by inferring your intent by how we write our XAML. Alright, so we're going to begin in this lesson looking at the grid control. Like any grid, it allows you to define both rows and columns to create cells. And then each of the controls that are used by your application can request which row and which column that they want to be placed inside of. So whenever you create a new app using the blank app template, you're provided very little guidance, as you saw here a moment ago. Let me just get rid of that. That's pretty much all you're given to get started. You get a single empty grid with no rows or no columns defined. However, by default, there's always one row definition and one column definition, even if it's not explicitly defined in your XAML. And these take up the full vertical and horizontal space available to represent one large cell in the grid. Now, any items that are placed between that opening and closing grid element are understood to be inside of that single implicitly defined cell. So I'm going to create a quick example of a grid that defines two rows just to illustrate two primary ways of creating rows and setting their heights. And so actually I've already taken the opportunity to create this. I'm going to go to a project called Row Definitions. You should be able to open this up and follow along. Or you can just pause the video and type this in as well. So here you can see that I want you to notice how that I have two rectangles. There's an upper rectangle and a lower rectangle. And those are defined through a series of row definition objects here. So you can see that I have inside of the grid, I have this property element syntax to define a collection of row definitions with instances of row definition created with their height property set. And here the first one has its height property set to auto, and its second row definition object has its height set to star. And then we have two rectangle objects, and notice that here we're setting the row that this rectangle object wants to put itself inside of. It wants to put itself inside of the row 0. So we can see that this is the first row, row 0, so it's 0 based. And then the second rectangle wants to put itself inside of the grid row equals 1. So it puts itself here in this row. So the first thing to notice is how the rectangles are putting themselves into the various grid rows, and then also how you reference both rows and columns using a zero-based numbering scheme like we saw here. Now the second thing that I want you to notice is this weird syntax, grid.row, and we'll also be setting grid.column in another example here. And these are called attached properties. And attached properties enable an object, in this case a rectangle, to assign a value for a property, in this case the row property, but it could apply to the column property as well, to assign a value for a property that its own class structure doesn't define. So nowhere in the rectangle definition is there a grid.row property or even a row property. These are all defined inside of the grid object. Now the reason why attached properties exist is really an advanced XAML topic that's not actionable at this point in your introduction to XAML, so I'm going to skip that topic. If you want to get deeper into the internals of XAML, then you should search MSDN for articles about both attached properties as well as the loosely related topic of dependency properties. But in a nutshell, attached properties keep your XAML simple. Let's just leave it at that, and then you can go off and explore that topic a little bit on your own later on. So the third thing that I want you to notice about this example are the two different row heights. The first height we set to auto, and the second row height we set to star. There are three syntaxes that you can use to help persuade the sizing for each row and each column. I use the term persuade intentionally. With XAML Layout, heights and widths are relative and can be influenced by a number of different factors. All of these factors are considered by the layout engine at runtime to determine the actual placement of items on your given page or your screen. So for example, this term auto means that the height for the row should be tall enough to accommodate all the controls that are placed inside of that row. If the tallest control, in this case you can see this rectangle has its height explicitly set to 100 pixels. If the tallest item is 100 pixels tall, then that's the actual height of the row, 100 pixels. If we were to change this to 50 pixels, you can see that the height of the row changes now to be half the height, to 50 instead. Let's change that back to 100. So therefore, auto means that the height is relative to the controls that are inside of that given row or column or whatever the case might be. Secondly, you see this asterisk. It's also known as star sizing, and it means that the height of the row should take up all of the rest of the available height available. So here's a quick example of another way to use star sizing. I created a project that has 3 rows and in the content panel. So here, let me get to star sizing. Great. Bring it down here. So again, you can see that we have 3 rows that are defined. Let me just get down here, like so. Notice the heights of each one of them. Putting a number before the asterisk, I'm saying of all the available space, give me 1 share of all the available space, or 2 shares of all the available space, or in this case, 3 shares of all the available space. So the sum of all those rows adds up to 6. So each 1 star is equivalent to 1/6 of the height that's currently available. So therefore, 3 star would get half of the height that's available as depicted in the output of this example. As you can see, it gets half of the available height. I also want you to notice off to the left-hand side that there are some visual tools that we can use to change the sizing. So for example, I can change from star sizing to auto or to pixel. I can also just type in the given value here, and that would set the height property in this particular case. Besides auto and star sizing, you can also specify widths and heights as well as margins in terms of pixels. So in fact, when only numbers are present, it represents that number of pixels for the width or the height. Now generally, it's not a good idea to use exact pixels in layouts for widths and heights because of the likelihood that various screens will be larger or smaller. So there's several different types of phones. There's several different form factors for tablets and desktops, things of that nature. And so you don't want to specify exact numbers, or else it's not going to look correct on a different form factor. Instead, it's preferable to use relative layouts like auto and star sizing for layout. Now, the one other thing that I want you to notice from this example is that the XAML control widths and heights are assumed to be 100% unless otherwise specified, especially for rectangles. And that's pretty much true for many different controls. Not all controls, like the button control, is not treated this way, but a rectangle, an image control, these are all assumed to be 100% of whatever space that's available, width and height. I also want to point out that a grid can have a collection of column definitions. And what I want to do is show you another example here. And so here you can see that we have a 3x3 grid, 3 row definitions, and then we see that we're also, with property element syntax, defining a column definitions collection that contains 3 columns. Furthermore, you can see that I put a text block inside of each one of the cells. Now, unfortunately, you can't see the numbers here on the designer. It's not representing them correctly, but if we were to run the application, you would be able to see that we get a different number in each cell. We'll make that smaller. You can see 1 through 9. Okay. And one of the things that I want you to notice, for example, in this very first cell in the upper left-hand corner, is that I'm not setting a row, nor am I setting a column. And so by default, if you don't supply that information, it's assumed to be 0. So we're assuming that we're putting this particular text block in row 0, column 0. Furthermore, if you take a look at this next text block, I'm setting the grid column equal to 1, but I'm not setting the row, meaning that I'm assuming that to be 0. And I do that here several times throughout this example. So relying on defaults keeps your code, again, more concise, but you have to understand that there's a convention being used here. All right, I have another example that I want to show you called alignment and margins. Let's bring this down. Most of this example should be pretty obvious if you stare at it for a few moments, but there are several finer distinctions that I want to make about alignments and margins. First of all, this example illustrates how vertical alignment and horizontal alignment work even in a given grid cell. And this will hold true in a stack panel as well when we talk about it in the next lesson. The vertical or horizontal alignment property attributes pull controls towards their boundaries. So by contrast, the margin attributes push controls away from their boundaries. So in this case here, you can see that the horizontal alignment, we're pulling this blue rectangle towards the left-hand side, and we're pulling it towards the top-hand side, okay? However, if we take a look at a example that has some margins defined here at the very bottom, this white one. So here again, we are pulling the horizontal alignment towards the left, and we're pulling the vertical alignment towards the bottom, and then we're setting the margins equal to 50, 0, 0, and 50. So you can see that the margin will now push the rectangle away from the left-hand boundary by 50. So you can see here that we get that little spacing on the left-hand side, and the margin is pushing the white rectangle away from the bottom boundary by 50 pixels as well. Now, the second observation that I want to make is the odd way in which margins are defined. And we already talked about this, so I'm not going to harbor on this in this lesson. Margins are represented as a series of numeric values that are separated by commas, and this convention was borrowed from cascading style sheets. So the numbers represent the margin pixel values in a clockwise fashion starting at the left-hand side. So in this case, left, top, right, and bottom. All right. A bit earlier I said that it's generally a better idea to use relative sizes like auto or star sizing whenever you want to define heights and widths. So why is it then that margins are defined in exact pixels? Well, Usually margins are just small values to provide spacing or padding between two relative values, and so they can be fixed without negatively impacting the overall layout of the page. I mean, if you want a small amount of spacing between two rectangles, 50 pixels will be enough whether you have a large or smaller size. And if it's not, then you can change it through other techniques that we'll demonstrate later on in this series. So let's recap what we've talked about so far. In this lesson, we talked about layout controls and how they allow you to define areas of your application where other visual XAML controls will be hosted. In this lesson, we specifically learned about the grid and how to define columns and rows, how to define their relative sizes using star and auto, and then how to specify which row and column a given control would request to be inside of by setting attached properties grid.row, grid.column on that given item, like a rectangle in this particular case, or whatever it might be. We also talked about how to set the alignment and the margins of those controls inside of a given cell and more. So grids are great, but they're really just one tool. You're going to likely use them along with other layout controls like the stack panel, which we're going to learn about in the very next lesson. So we'll see you there. Thank you.